Hey, in this video, I'm going to introduce you to the integration by parts formula, and we're going to run through a quick example of how to use that formula. The integration by parts formula looks like this. I am generally using this when I have a couple of expressions multiplying within an integral that I'm trying to integrate. And so you're going to choose part of this function to be u and the other part of it to be dv. And then we're going to complete the right side of this formula. So I'm going to need to identify u, v, and du all to complete the right side of this formula when I'm using it in a problem. So for example, I've got x times sine of x I'm trying to integrate. So I have a product here, which is not the only time you use integration by parts, but it is the most common example of when we would use integration by parts. And I've got the formula, the right side of that formula up here on the top, just to remind us, these are all the parts I need to identify. So you always start out by picking what is going to be your u in this formula, and then what will be the dv, and then we'll find the rest of the pieces to fill out this formula. For this one, I'm going to choose the u to be x and the dv to be the rest of this, so the sine x dx. So I have a piece of the formula I have the u that I need to identify du and v to complete the formula. So du is going to be what I get from taking the derivative of u, which is equal to x. So the derivative of u will be equal to du equals dx. And then to find v, I have to do the antiderivative of dv. So I'm going to be integrating sine of x dx. So the integral of sine is going to be cosine. So now I have all the pieces of the formula. I have my u, my du, and the v all ready to go into this formula. And so I'm going to start filling out the formula. So the first piece of it is u times v. So I will multiply those two together. So x times cosine x. And then v du. So that's going to be the cosine of x times dx. And that is going to go inside of an integral. And noticing on the formula, there's a negative in there. So the u times v will be positive, and the v du is going to be negative. So if I start filling out this formula, the integral of x times sine of x dx is going to be equal to x times cosine x minus the integral of cosine x dx. So I filled out the formula, but I still have an integral here. So the last step in this is to go ahead and integrate that negative cosine of x, which will give me negative sine of x. So I get a final answer of x times cosine x minus sine of x. And then, of course, I need that plus c, that constant of integration there. And this formula also works if it was a definite integral where I have limits of integration on my integral. Something to keep in mind when you're doing this is how to choose u and dv. Usually I start out by picking the u, and you want to pick the u to be something that is easy to take the derivative of, and where the du is going to be simpler than the u that you started with. The whole idea of this integration by parts formula is to make things simpler. And then for the dv, because I have to integrate it, I want it to be something that is relatively easy to integrate, definitely something that would be easier to integrate than u. And a good rule of thumb for this is to remember the acronym LIPET, L-I-P-E-T. This gives us kind of an order of what we would choose for u. So my first choice in an integral for what u would be a natural log. Harder to integrate, much easier to take the derivative of. So if I have a log of some kind, like a natural log of x, inside my integral, that is my first choice for u. If I don't have a log in there, but I have an inverse trig function, like arctan or sine inverse of x, then that would be my first choice, absent a logarithm. If neither one of those are in there, then I go with a polynomial. So I have an x squared or x squared minus 2 or something like that. Some kind of polynomial, that would be my third choice for u. If none of those three are in there, then I would go with an exponential or a trig function. And these are kind of interchangeable, but they are my last choices for u. So if I have, say, an e to the x or a sine of x, like on the example we just did, that's my last choice for u. Any of these other ones are going to be a better choice for you when using this formula. And then whatever's left over ends up being your dv. Okay, so that's how you use the integration by parts formula. Now, in the notes that go along with this lecture, I want you to go ahead and try to solve this integral now, x times the natural log of 5x, using the integration by parts formula. And have that ready to go for class so that you can discuss this and see how it went.